Hi, my name is Robert Heinrichs. I'm a lecturer at ASU here and I'm from Germany. Back in Germany, I study computer engineering and my interest lies in the area of advanced driver assistance systems in vehicles. So basically improving the comfort and the safety of drivers in cars, which is closely related to the course SER456, Embedded Interfaces, Sensors and Actuators. So in this course, we're looking at embedded systems. This course is an introduction to the embedded systems area. So we will be taking a closer look at microcontrollers, sensors, and actuators. These enable us to perceive the environment and manipulate the environment. And we're learning the most important aspects of embedded systems and apply it to a semester-wide project. So let's talk about the prerequisites. Knowledge in object-oriented software development is important. So this would be your SER200 or CSE 205 course. It is important to understand logic gates and the different number systems and their arithmetic to convert between, for example, the binary numbers into decimal and hexadecimal. This was covered in SER 232. Knowledge with the C language is helpful. We will be using the C language in this course, so any knowledge there will help you. Also, if you have any prior knowledge in embedded systems, this helps too, but this course is designed to give you all the necessary information and knowledge that you need to complete this course. All right, so let's talk about the course expectations. What I already said in the prerequisites, the course is designed so that you don't have to have any prior knowledge of electrical engineering or embedded systems. So in the beginning, we will talk about the basics of electrical engineering so that you're able to solder and build your own embedded system. Again, we cover the fundamental aspects of microcontrollers. One special thing about microcontrollers is that they act in a digital world. So everything that is inside a microcontroller is just zeros and ones. But we live in an analog world where we have different numbers too, and not everything is binary. So there is a necessary transition between those two worlds that we will cover and talk about. So we will cover things like the analog to digital conversion, the digital to analog conversion, things like pulse width modulation, and also we'll cover interrupts, which are helpful to develop your embedded system. Reading sensor data is one way to capture the information of the real-world environment. These can be done in either in analog or in digital. And you can read different information like button presses or temperature, the light around you, accelerations, or even sound. But these are just a few examples. So the next thing is we want to interact with the environment. So we need actuators to manipulate the environment. And this can be done in different ways. So for one, we have LEDs that can signal the user any kind of information. We have displays where you can actually display information like a temperature with the digits. Or you have motors so you can influence and manipulate something around. So this way a robot can walk. During that, we will apply different software engineering techniques, for example, state charts, to improve and ensure the system quality of the system you're building. Of course, we also want to talk to maybe different devices, connect the embedded system to the internet so you can pull information from there. So we also cover communication. These are, for example, UART, I2C, and SPI. And once we've covered all that information, you will apply everything into your semester project. So this is free of choice. You can pick whatever project you feel comfortable with and you're interested in. In the recent semesters, we had very interesting projects like walking robots. We had some students creating a smart home. There was a soda can instant cooler that would cool down your soda within seconds. We had a smart tube that is connected to the internet and can display information and messages. We even had an automated dice roll tower. So with your smartphone, you could initiate a roll and the tower would turn and read the dice value for you. But this is not limited to that. These are only a few examples. You can create toys for your kids. So whatever you can think of is possible. All right, let's talk about the course outcomes. What will you be able to do after you've finished that course? So first, you will be able to understand and apply the fundamental aspects of embedded systems to problems in that area. Next, you will be able to interface with a wider range of digital and analog sensors and actuators to perceive information and manipulate the environment. You will be able to utilize the software engineering techniques that we've covered in that course to help you build high-quality embedded systems. And in the end, you are able to create entire embedded systems, building circuits with the necessary electric components and implementing the software in C for the microcontroller to make your embedded system real. All right, so I'm the course coordinator for this course. I've created it, but I will not necessarily teach it. So you can always contact me during my office hours. These are posted on your Blackboard shell, and I hope that you enjoy this course. Thank you.